Now that we know what functions are, in today's lesson we're going to learn about linear functions. Did you know that there are three kinds of equations that you can use to represent a straight line? In today's lesson we're going to learn how to translate those equations into a graphical form, and also learn how to take that graphical representation and represent it in an equation form. The first equation is known as the slope-intercept form. In this equation, there are two parameters you need to know, m and c. M is your slope, c is your y-intercept. M, you can calculate it the same way you used to in geometry. And m can be greater than 0, and m can be less than 0, and m can be equal to 0. When m is greater than 0, you can draw it like that. And when m is less than 0, your slope changes to be like that. And when m is greater than 0, you just have your y-intercept, and you can just draw y equal to c. In the second equation, you have x1 and y1 as your points, and you have your m as your slope, and that is the point-slope form. You use this equation when you have m and x1, y1. The last equation is your general form. You have a and b as your coefficients, and you also have c as a constant. And these have to be integers. Going to examples. Example 1. Graph the equation y is equal to 2x minus 2. In this equation, you can already tell that this is in the form y is equal to mx plus c, and here you can say m is equal to 2, and you can already see that c is equal to minus 2, and this is your y-intercept. So now that you know your y-intercept, you can start drawing the point c is equal to minus 2. You go to your y-axis, which you need to label. So you go there, say that is minus 2. So you have that point. So what do you do after that? How do you get the second point when you're given your gradient? So from here, you know that your gradient is given by m equal to y2 minus y1 over x2 minus x1. And this means your rise over run. In your slope, this you go up the y-axis, and then here you go the x-axis. So from the point 2, you're going to have to go up, and then you go to x, depending on the values. So you know that m is equal to 2 over 1. So that means from the point minus 2, you're going to go up 2 points, and that will take you to point 0. But that's not your point, because you have to go 1 unit via the x-axis. So that's your final point, and you can draw that, and that is going to be your equation. So to finish this up, you can also write your x-intercept. Although you can already see that you have that intercept, just to make sure that you are in the right track, you can say my x-intercept is when I make my y equal to 0. So x will be, you're going to put 0, and you have 2 times x minus 2. Put 2 on the other side, you have 2x, and then x is equal to 1. And remember, we went 1 unit up, 1 unit via the x-axis, and that point is 1 is to 0. And that you have your graph. So you are able to take your y is equal to mx plus c equation and take it to your graphical representation. Example number 2. You have your f of x equal to minus x plus 2. And the equation is determine the coordinates a and b. Because sometimes you'll be asked in a way that you'll be given the graph already drawn for you. Then you have to determine its point. So we can see that this form is also in the form of y equal to minus x plus 2. And we can tell, okay, the gradient is minus 1, and your y-intercept is 2. And also A, you can tell from A that this is your y-intercept. So your y-intercept is equal to y is equal to 2. But this is not the answer because the question said, what is the coordinates of A? So A is equal to 0 and 2. Because when you get your y-intercept, you have to make x equal to 0. Do not forget that when they said coordinates, you need to give it in this form. Going to B, you can see that B is your x-intercept. That means you have to make your y equal to 0. So when we make y equal to 0, we have minus x plus 2, and then we have x is equal to 2. And B is equal to 2 is to 0. And that is your full answer. You have your B, you have your example number 3. Graph the equation y minus 2 equal to 2x plus 2. You can see that this equation is in the form of y minus y1 equal to m of x minus x1. So here you can already see that you already have x1, y1, which are your first points, which are minus 2 and 2. And you also have your gradient as 2 over 1. So you draw your points, which is minus 2. We'll say that is the point, minus 2 and 2. You have your gradient of 2. So from point 2, your y-axis, since we said this is your rise, this is your run. So you're going to go 2 points up, and that's 2 plus 2, meaning that is 4. But then you move 1 point, positive 1. So that is your next point, which is minus 1 from minus 2. So you have those 2 points. From here, you can continue and say, from 4, I have to move 2 points up. That will take me to 6. And I will have to move 1 point from minus 1 to 0. And that will get me there using your slope. To test if really that your y-intercept is equal to 6, you can calculate it again just to be sure. So you say y minus 2 is equal to 2 into 0 plus 2 because we are calculating the y-intercept. So y is equal to 2 times 2 is 4, then plus 2. So we have y equal to 6. And that is a y-intercept. And we also have y equal to 6. You can continue to calculate your x-intercept. Example number 4. Sketch the graph of 2x plus 3y is equal to 3. Here you can already see that this is in the general form, which is ax plus b, y equal to c. And this we can change to be y equal to mx plus c. So you can take your points or you can calculate from here. But for the purpose of this lesson, we're going to calculate from here. But for yourself, you can change it. So to calculate our y-intercept, we can make x is equal to 0. And we have 2 times 0 equal to 3y plus 3y equal to 3. And we have 3y equal to 3. And we have y equal to 1. And we can see that, okay, we have 0 is to 1 as our first point. And we can also calculate our x-intercept by making y equal to 0. Meaning we're going to have 2x plus 3 times 0 equal to 3. That means we have x equal to 3 over 2. So we can say, okay, 3 over 2, if this is 1, 3 over 2. And then that means that is our graph. So this session is going to be divided into 2 lessons. For the first lesson, we are done. We are able to take an equation and change it into a graphical form. The second lesson will be changing the graphical representation into the equations.